Have you ever watched a rocket launch and your brain just kind of short circuits trying to figure out how that thing gets off the ground? I mean, we're talking about a machine that weighs millions of pounds just leaving the planet. Well, today we're going to dig into the physics behind that incredible sight.
So, let's get right into it. What's the secret sauce? What does it really take to hurl something that big towards the stars? It's not magic, not by a long shot. It's actually a story told with just a few incredibly powerful laws of physics. And we're going to walk through that story, one step at a time.
All right, so first things first. Before we can make a rocket fly, we kind of need to agree on how to talk about it, right? We need to learn the basic language of motion.
Okay, so let's kick things off with velocity. Now, I know you see that formula on screen and it might look a little scary, but don't worry about it. The idea is super simple. It's basically speed, but with a destination in mind. You know, if you're driving 60 miles an hour, that's your speed. But if you're driving 60 miles an hour north, that's your velocity. For a rocket, that direction part is, well, it's everything.
Now, picture that rocket just sitting there on the launch pad. Its velocity? A big fat zero. It's not going anywhere. This is where the action begins. Acceleration. It's the pedal to the metal moment. It's all about that change in velocity, going from 0 to thousands of miles per hour in minutes. That incredible, powerful change. That's the heart of the launch.
Okay, so we know we need this insane acceleration, but how do we actually make it happen? Well, you can't just wish for it. You've got to play by the rules of the universe, and the guy who wrote that rule book? None other than the legend himself, Sir Isaac Newton. This brings us to a really cool idea called momentum. You can think of it as the quantity of motion, or, the oomph something has when it's moving. Our rocket, sitting there, it's got tons of mass, but zero velocity, so zero momentum. The entire goal of the launch, the whole point, is to give it an absolutely enormous amount of momentum, all of it pointing in one direction, up. So, the million-dollar question, how do you give something momentum? You've got to push it. You apply a force. And this is where we get to probably the most famous equation in all of science, F equals ma. Force equals mass times acceleration. It's so simple, but so powerful. To get our massive rocket accelerating like crazy, we need an equally massive upward force.
But wait a second. Where does that push come from? A lot of people think the rocket pushes off the ground, right? Like you push off the floor to jump. Well, that's actually a huge myth. In fact, rockets work better in the total vacuum of space where there's nothing at all to push on. So what in the world is going on here?
The answer is just so elegant. It's Newton's third law. For every action, there's an equal and opposite reaction. The rocket's engines are basically throwing stuff, a whole lot of hot gas, downwards, really, really hard. That's the action. And the reaction? All that gas, as it's being thrown down, pushes the rocket up with the exact same amount of force. The rocket is literally pushing against its own exhaust. That's it. That's the secret to liftoff. Okay, so we've got our hero of the story, that powerful upward thrust created by the engines. But you know, every great story needs a great villain, an antagonist, a relentless force trying to pull our hero back down every single inch of the way.
And that villain's name is gravity. It's always there, always pulling. That formula you see on the screen, it's the math behind an invisible rope tethering the rocket to the center of the Earth. So for our rocket to even begin to fly, it has to fight the gravitational pull of the entire planet.
Let's bring that back down to Earth, literally. Here on the surface, for every single kilogram of that rocket, gravity is pulling down with a force of about 9.8 newtons. So what's a newton? It's roughly the weight of an apple in your hand. Now imagine not one apple, but millions and millions of apples, all tied to the rocket, pulling it down. That's the force it has to beat.
So it all comes down to this. A launch is basically a giant cosmic tug-of-war. You've got the upward thrust from the engines pulling one way, and the entire mass of planet Earth pulling the other way with gravity. For liftoff to happen, it's simple. Thrust has to win. The moment that upward force is even a tiny bit greater than the downward force of gravity, the rocket starts to climb.
But winning a fight like that doesn't come for free. It has a cost, a huge one. And in the world of physics, that cost is always paid in the same currency, energy.
So in everyday life, work can mean a lot of things, but in physics, it's super specific. It's what happens when you apply a force and it actually moves something. The rocket's engines,
They're doing an almost unimaginable amount of work, applying that huge thrust force over hundreds and hundreds of miles as it climbs.
So where does all that work go? It's not just disappearing. It's being converted, transformed into two different types of energy. As the rocket gets higher, it's storing up potential energy. That's the energy of position, kind of like stretching a giant rubber band against gravity. At the same time, as it gets faster, it's gaining kinetic energy. That's the raw energy of pure motion.
And this is where it all ties together so beautifully. It's a perfect energy exchange. You start with chemical energy locked away in the rocket fuel. You burn the fuel, releasing that energy to do work, to push the rocket. And that work gets perfectly converted into the energy of height and the energy of speed. Nothing is lost, it's just changing forms.
So you see, these aren't just a bunch of random formulas. They're a sequence, a recipe. It's the 4-step playbook for making anything move. Step 1, you describe the motion you want. Step 2, you apply a force to make it happen. Step 3, you make sure your force is strong enough to beat whatever's pushing back. And Step 4, you provide the energy to pay for it all. That's the story of motion.
And here's the coolest part. That exact same 4-act story that launches a rocket to another planet, it's the same story that plays out when you throw a baseball or when your car takes off from a red light. The physics of the cosmos is the physics of your backyard. So, think about it. Where else in your world do you see this story playing out? Once you start looking, you'll see it absolutely everywhere.